working in a variety of topics in economics, perhaps closer to our interest in game theory. And lately he became interested in problems of minority language, language competition, language content. And then he discovered that there were some physicists working on these things. And he had the courage to contact us and to try to discuss with us what we were doing and which is our common interest. And he has even had the courage to come here and accept giving a seminar. And I thank him for that, and I'm glad that he's here and that we can learn from a different point of view on this topic, and from there on see which way we can go on discussing and finding new ways now in physics, economics, and language. Thanks for having me.
Yes, thank you. Very pleased to be here. Well, it is true that in economics you don't find this type of topic, even though competition is one of the central topic for economists, at least for theoretical economists. In game theory models competition. But then competition between languages is a minor subject in economics. It is natural for me to deal with this topic because coming from the Basque country, I mean, it's in the air. I mean, the competition of languages. So, Uriarte, my co-author, was a student of mine who studied in the Basque country, then went to San Diego, and now is at the Complejos. So we started a long time ago dealing with this, how to model what we call the language game. So let me introduce the paper. Okay. So you see, we are dealing with societies with two official languages. As you can say, as you can see, they may have different status. So in your papers, you make the assumption concerning the status. Many times I've seen in your papers the same status, right? Here we don't care very much about status, although we can imagine that they have a different status. Two official languages, A and B. Obviously, we follow the notation. A is the big one, the dominant language, and B the minor. And then you have two types of agents, bilingual ones, a minority able to speak both A and B. And the proportion of bilingual is alpha, and then the monolingual agents. The proportion is 1 minus alpha. We are assuming that alpha not only is smaller than 1 minus alpha, but also much smaller. Much smaller. So examples of this type of societies, well, there are some here. Welsh and Scottish Gaelic competing with English, Basque competing with French and Spanish, Breton, Catalan, Occitan, so on, competing with French, Sami, Frisian, Aboriginal languages, Native American languages, competing with English, Spanish, French, Portuguese, and Dutch, in Russia, etc. Initial implications. Since we are assuming that everybody speaks A, we don't have dynamics for A. No populational dynamics. Because the language A has reached, the boundary, the upper boundary, 100% of the people know the language. So it is only B that needs to increase its population share and expand its use. So therefore, only the dynamics of B is for us empirically and theoretically relevant. So therefore, the model by Adams and Strogat is not valid to study this CC. Right? That's what we think. So as for the dynamics of B, we could study the expansion or contraction of alpha, or studying given alpha, study the interactions that occur inside the bilingual population and see if in those interactions between bilingual people, which language is used. So we are going to concentrate on two. When two bilingual people interact, which language do they use? So the first thing to take into account is that alpha is a given, absolutely given. So it's like a snapshot. This is alpha. Let's say 34% of the people are bilingual. What's going on inside that bilingual population? And then the first assumption is that decisions are taken under imperfect knowledge. This means that I know that I am bilingual, but I don't know when I meet you whether you are bilingual or not. I don't know. You don't know that I am bilingual. So there is imperfect knowledge. So therefore, we are taking bilingual people away from their familiar surroundings. They meet somewhere else. But outside their familiar surroundings. They all know, I mean, there's common knowledge about the proportion of alpha and 1 minus alpha. Everybody knows, well, alpha, B, the language B, just a few people speak. They all know. And then they all know that everybody knows A. That's common knowledge. The first assumption, the distance, the linguistic distance between A and B is so high that communication is only possible in one language. So therefore there is no passive bilingualism. So that you can speak in B, I don't speak, but I can understand, and I understand what you're saying, but I answer in A. So that's not possible. Either they speak in A or speak in B. Right? Another implication is that Mira and Paredes assume similarity between A and B. So therefore, that assumption is not made in here because of the distance. I suppose patriarcha and Alepanen, maybe it's patriarcha here. I guess you assume perfect knowledge because you are dealing with people from some areas, the strongholds of B. So therefore, they know each other, they know that they know, and everybody knows that you know, that I know, and so on. I speak B. So it is common knowledge, so therefore there is perfect knowledge. So we don't make that assumption. We assume that bilingual people, bilingual speakers are loyal to B. They prefer language B. So that's the notation that we make in economics. B is preferred to A. Right? So now, payoff situations. When two bilingual people happen to coordinate in language B, they get a payoff M. Monolingual or bilingual players by choice may coordinate in A, and then they get payoff N. And then the third situation is when a bilingual player wants to talk in his or her preferred language, but fail to do so, then that agent suffers a frustration cost, which is C, and therefore the payoff that agent obtains is n minus c. Right? So now the assumption 3 is the ordering of the payoffs. When two bilingual people coordinate in their preferred language, they obtain the maximum payoff, which is n. It is bigger than the natural payoff n, and bigger than c positive, greater than 0. So these are the assumptions.
Why is m greater than n supposed to be greater than n?
Yeah.
Why will get bilingual players more?
Yes, because there is a kind of sociolinguists they say this. I mean, there is a kind of discovering that we belong to the same language community, and then we are conscious that B is in a bad state, so we are using the languages. So it's a kind of reward to that coordination. We are using B. I prefer to talk in B. So, and then I realized that with this person I'm using my preferred language, and the same for the other. I'm using my preferred language. Okay. Any more questions? Yes.
When the bilingual and monolingual meet, the payoff is always the same for both?
Yeah, well, if the bilingual has decided to use A, then the payoff is N. Because we say monolingual or bilingual period by choice.
The last case, when one is frustrated, what about the other one?
Yes, because in this case, the bilingual player wants to use B. And then start the conversation using B. But then the answer of the other is, sorry, I don't speak B. And then he's forced to change to A.
What is the payoff of each one? Is the same, N minus C?
No, the monolingual gets N.
Okay.
We'll see now. Yes.
This is a one-shot game?
Yes, so far is a one-shot.
But,
so far. But then we're going to do a...
But it makes sense to have a one-shot. I mean, when you try to communicate with somebody, if I try B and he replies in A, I switch to A, and not again.
Yes, that's one shot. We'll see later that this will happen many times to many people, and then we have to approach in a different way. But so far, the analysis is one shot. Yes. And then the game they are going to play. So these are the actions of bilingual revolt A or B. The monolingual doesn't choose because he only knows A. And then we try to model the initial phase of a conversation. So imagine two people interacting. They could be monolingual. One could be monolingual, the other bilingual. They could be both bilingual, right? So this model, these four situations, four events are modeled here. By the way, we have an equivalent representation of the game here. From these two, I prefer this one. In economics, I mean, they will tell you, now, put nature at the beginning, right? And nature chooses the nature chooses the nature of each agent. It could be the first monolingual, the first bilingual, the second monolingual. The first is the one who is starting the conversation, the one who says good morning or whatever. The second event is both bilingual, the probability alpha squared. The third is first monolingual, second bilingual. So these are the probabilities, right? With this probability occurs this event, and then both monolingual. I say that I prefer this one because it is a more sequential. Nature chooses first the type of agent who starts the conversation. maybe the language game is not the correct name. Maybe the conversation name is better, because we are trying to model the initial phase of a conversation. I mean, the phase where the language of the interaction is going to be chosen. So nature chooses whether the one who starts the conversation is bilingual or monolingual, with those probabilities alpha, bilingual, and 1 minus alpha, monolingual, right? And then if it is, of course, if it is monolingual, then the action is A. The monolingual cannot choose, right? So imagine if the interaction in a shop, right? And then does the shopkeeper, the first one? The shopkeeper may start the conversation saying which language I'm going to use. We say in Spanish. Buenos días, right? Because monolingual. And then if it is bilingual, he may choose. Imagine it's in Basque. I'm going to put it in Basque. Egunon, buenos días. Egunon, or buenos días. Okay. And then comes the second one. Nature chooses the type of agent that the other is, whether bilingual, alpha, or monolingual, right? So, and then you have if this one has started the conversation saying egunon, and then this one happens to be bilingual, reaches this node where the second agent must choose the language. Okay? He can reply with uno, because it's bilingual, say uno, and then they obtain M, maximum value, because they have coordinated in the language they prefer. Or he may say, well, buenos días, whatever reason. Okay, the interesting thing is what happens here. This one is bilingual, and instead of saying egunon, say buenos días, ¿qué desea usted? And then the second one, if it is bilingual, if it is monolingual, well, buenos días, ¿qué desea usted? Pues deseo esto, lo que sea, ¿no? If it is monolingual. If it is monolingual. Okay. Buenos días, ¿qué desea usted? Imagine that the other is bilingual. Then he doesn't know in which node it is. This node is coming from a monolingual. He doesn't know whether player one is monolingual or bilingual, because he's hearing A, buenos días. So the information is imperfect. He doesn't know whether it's here or here. And then he must choose between answering in B, or in A. All right? He may risk of having a frustration cost, because he has heard buenos días. He may risk and say, well, I'm going to use B, right? And then necesito, so it's risking. And then, since we are coming from here, actually the first one is bilingual, and then he answers in B, he is revealing the nature. I'm telling you that I'm bilingual. Because he's using B. And then he may switch code here. The first one has another information set, switches the code and then comes back to B. Buenos días, Negunon, and then goes on the conversation in B. Serbia Rosu, etc. Well, this is I know that the game, well, is a bit complex. The thing now is how strategies are constructed. How strategies are constructed here, because doesn't work. So pure strategies of player 1, player 2. You have BB, BA, AB, and AA. Just to tell you how they are built. Come back here. The strategies are are ordered elements. For instance, strategy BB for player 1 is the following. Player 1 has 2 information sets, and then BB is built as follows. Here he chooses B, and here B. Right? So this is the combination. In here I will use B, and if I reach here I will use B. BA will be, I choose here B, and if I reach here, I choose A, BA. AB will be A here, buenos días, and then if I hear that this one tells me unon, I will switch my code, and then I will use B, AB, and then AA. Okay? So these are, so there is an order in the way strategies are built. The same for player 2. Player 2, I mean the combination is the following. Player 2 has 2 information sets. This one, which I call minority languages, because it is rich when this player 1 is using the minority language B. So when it is used minority language, we reach here with probability greater than 0. So has this information set, and this one, the majority language. The majority language is rich when player 1 is using A. Whether bilingual or monolingual, we reach here. So it's combining in the following way. The strategy BB is built as follows. B here, and then B here. BA is B here, and A here. And AB is A here, and B here, and then AA. A. So that's the way. There is an ordering. Okay? So then we have this pure strategy for bilingual players. Of course, this is one thing that you should know, that pure strategies do not include the action A of a monolingual player. Why? Because it's kind of redundant to put here action A when it happens that the player is monolingual. So it is assumed that you should have an A here, action A from a monolingual, right? But we don't care about that because they don't make choices. What matters here, what's going on with the agents that do really make choices, right? Another thing is that for player 1, BB and BA are equivalent. So therefore, we only care about one of them. And then we are going to care about BB only. You see, if player 1 uses B, then the game goes this way. So it has no consequences what happens in this side. If it uses B, and then this is what really matters, right? So BB and strategy BA are the same, have the same consequences. So we only need to take care of one of them. So it is only BB that we are going to use. So now, when you have these strategies, these pure strategies, which is the language used? So we have here the language matrix. So we have 16 entries. You see, A, there are many A's here, and then B's. Obviously, when you use B, and the other one uses BB and BB against BA, it is B, the language used. BB against AB, BB against AAB, the consequence is language A. If you don't see it, just tell me, because I go back to the tree and then to show you. This is interesting. AB against BA, and then the language used is A. So AB and BA both are willing to use B, both. But then there is a miscoordination, and then they end up, they are bilingual. They wish to use B, but then they speak A. Yes.
So what is the level of rationality of the agent? Because if I hear B
yes.
and I speak B, I mean, I don't see how I will coordinate in A. Because I know that he's bilingual and speaks in B, he knows that, I do, then we speak in B.
Yes, that's it's a miscoordination. Rationality is the maximum. We're assuming the maximum.
No, but
They are hyper-rationality. Hyper-rationality.
no, but I think that this piece of, I mean, if I know there are bilinguals and monolinguals,
Yes.
then once I listen to B,
Yes.
there is no more game because
Yes. Yes.
if I'm B, I will speak B and not A any longer.
Yes, and don't forget that when you start with B, you are taking a risk. The risk of suffering a frustration cost and obtaining the minimum payoff. Right. Now, I'll show you now why there is a miscoordination that is going to be the most important thing here. I'm player 1, you are player 2. I'm playing AB, you are playing BA. So your strategy is the following. You are playing BA. If you reach here, you are going to use B. So, and then here, you are going to use A. That's your strategy, BA. Don't forget. BA. You are playing BA. BA means you are going to use the language you are addressed to. Because here you are using B. You are using B if this node is reached with positive probability. Because in this case you have heard B. You have heard egunon, and then you will answer with egunon. Here you use A. You use A because this information set is reached when the speaker is using A. So you are answering in the language that the first mover has used. Here in A, here in B. That's your strategy. You are using the language that the first one is using.
Yeah, but
And then my strategy is AV. AV. I'm the shopkeeper and I'm telling you, buenos días, ¿qué desea usted? So, the game goes this way. Buenos días. So, we reach here. And then what do you say? You're using here A. You're using...
yeah, but I understand that if you just play the games blindly, you can get the strange result. But what I'm saying is, if the players are rational, I mean,
Yes.
I still don't see the point why a B is going to use a A as a first case.
And be careful that the question
Well, what frustration?
But there is no, I mean, there's,
Yeah, you try to avoid the cost. You are risk averse. You are risk averse and then trying to avoid the minimum payoff, the frustration cost. And then
but there's another, because in one case you are allowing for two solves, right? These two greens, they have two solves.
they have what?
I mean, two trials. First I say something, then you reply, and then I say something. If you allow for the same thing to the left path, for two solves, so then I speak Vasco, then you speak Spanish, then I say, you speak Spanish, then I speak Spanish. There is no frustration.
No, but we were dealing with this one.
No, but why don't you allow for a next round in this path?
Because, well, you coordinate in one language and then the interaction goes in that language.
No, then I'm missing something. On the left, you speak B, right?
Here.
Then it's B. Then you go to the minority and then it speaks A.
No.
No, the strategy for the second point is elaborated in a different form. It's not the same. The strategy is what you do in the minority language and what you do in the majority language. That's your strategy. So if you ask them, a BA means that in the minority language case you take B, the last, and the majority you take A.
That would be the case.
Not the
But we're talking about this one, this strategy, this combination. So if you are saying buenos días, and then we go here, and then A. Buenos días, buenos días. Buenos días. So we reach to this information set, and then your strategy says here I will use A. I will use
No,
A.
the strategies I understand. What I understand is, I mean, if you just allow me for, so you say something, I say something, and on the game, fine. But if you allow me for more, as you are allowing there, you have the first player is talking twice.
Yes, but
Then there is no frustration. Even
you mean repeat this many times so that you have the opportunity.
I think the left side, yes. The second from the left. The second branch from the left.
This one?
That one. Why not give a second option to the first speaker? Why not continue the game?
Here.
Here. Then give a second option to the first speaker. To use B again.
Well, you see, here, what happened is that B.
Egunon, buenos días, egunon.
No, but B, and then, the
And
rational thing to do here, by backward induction, is that this one must choose B because of the maximum payoff. This is a subgame. In this subgame, 2 must choose B. If it is reached with positive probability, because M is bigger than N. So, the action to be chosen here in this subgame, since M is bigger than N, is B. It is here then there is a code switching. And then this can go on and on, but you can reduce all that to this subgame. In this subgame as well, this is a subgame. Player 1, the best action is B, because M is bigger than N minus C. So that's the ultimate. So backward induction this is the optimal. But I mean, your question is related with how strategies are built exactly and where, and what's the path. Okay. Anyway, we can go on talking afterwards if you want. Well, we can reduce the problem. We can reduce the problem because bilingual speakers are loyal to you. So therefore, there is a kind of tacit agreement between them. Inside the bilingual population, there is a tacit agreement that when in a conversation one speaker reveals his bilingual nature by using B, then the other, if this happens to be bilingual, will not play a strategy blocking the use of B. So therefore, if player one reveals his bilingual nature by starting with B, saying egunon means I'm telling you that I'm bilingual. I'm telling you. I take the risk of telling you. Then player two will not play buenos días. Or buenos días in any case. Player two will play, well, egunon. The same, if player 2 plays BB, player 1 will play BB or AB. It will not play A. So this will reduce the game so that we have this. So we have four outcomes, and there is, in 3 of them, I mean the coordination is in B. But we have here A, and I put a big one. So that's the problem. That's going to be the problem. Okay? So therefore now the strategies are reduced for both players because of the tacit agreement that exists between the bilingual people. So player 1 will use BB and AB, right? And player 2, BB and BA. AB and BA imply a miscoordination. They are ready to use B, but they don't coordinate. This one is saying, well, I'm going to use B if the other is using B. So I put the risk for the other. I don't take the risk. But if the other one is using B, I will switch from A to B. And then here is the strategy that you were using. You are saying, I will use B if the other is using B. Otherwise I will use A. And then the coordination, the miscoordination happens. So now, this is a bit technical. You see, now we can change the parameter of the cost, frustration cost, and if it is equal to the benefit of coordinating in B, then the only Bayesian perfect equilibrium is, well, we have 3, but from these 3, only this is then composed of non-dominated strategies. So this is the case. So we are here. The language spoken here is the miscoordination we are talking about. Is A. If the frustration cost is bigger than the benefit, then the only Bayesian perfect equilibrium is this one, again the same, if you see. The language spoken is A in the equilibrium. So now we have the third case. In the third case, suppose that the cost is smaller than the benefit. Then we have, in pure strategy, we have this equilibrium. In both, the language spoken is B. So we have to concentrate in regime 3, because this one, equality doesn't make sense. I mean, any perturbation will convert that in inequality. I mean, these are the impossibility cases because regime 3, the language spoken is A. We don't go too far with that. Let us assume that in real situation happens this. Suppose that the cost, frustration cost, is smaller than benefit. And then, well, we have some possibility here, but that's not the end of the story. I mean, the story starts now because we are going to concentrate our analysis on regime 3, right? So let us reword the strategies. You see, so we have this strategy, BB and AB for player 1. I mean, it's a good exercise for you to understand all this, to take the role of one of to choose to be in the role of one of the players, so that you are always player 2 or you are always player 1, so that you know on which side of the game you are, right? I mean, to recall the strategies, right? So BB and AB, BB and BA. So we can reword the strategies. S1, and strategy, by the way, is a kind of command. If I go on holidays and I tell my friend, well, I'm going to Palma on holidays. Meanwhile, you play the game. And I tell my friend, you play this, use always B. It's a kind of command. Don't forget, use always B in any case. Whether you know for certain that you're speaking to a bilingual individual or not, use always B. That's the strategy BB. BB and BB. Use always B. And the other one is, I tell my friend, use B only when you know for certain that you're speaking to a bilingual individual. If you know for certain. Because in that case you are going to get the maximum payoff. If you are not certain that the other is bilingual, use A. That is strategy AB, yours, and that's my strategy, BA. AB is, for player 1, AB is, I start the conversation saying buenos días, and if the other is answering me uno, the other one is revealing his bilingual nature, then I will switch my code from A to B. That's AB. Because in that case I know for certain that the other is bilingual. And then BA is, well, I will use B if the other is telling me uno. If he's telling me buenos días, I will use A. I know that to see this, we have to have in mind the tree, the game tree. So, in this case, we have, for the bilingual population, a strategy set which is common for them. So because so far we were dealing with player 1 and player 2. And I'm going to little by little changing my approach. So we have this set of strategy which is common for both S1 and S2. S1 is BB for both. S2, if you start the conversation, is AB, and if you follow the conversation, is BA. Right? So that's the dynamic approach. So we are passing from one shot game that is played once to the situation in which this kind of one-shot interaction is not realistic because the game is played many times by many different people, and the solution is not an individual one but a social construct. The game is played continuously, right? So we assume that the bilingual population consists of a finite number of individuals, but large, who play a certain pure strategy in a two-player game. And then the interaction model as pairwise random matching between agents of the bilingual population. Imagine that we are the bilingual population, and then I choose one here, another one here, and then they play the game. Obviously, in this population, some of you play S1, some of you play S2. So the probability then is equal to the proportion of people playing S1 and S2. Right. Let n be the total population, the bilingual people, and then let x this proportion, the proportion of bilingual agents playing pure strategy S1. So everybody is playing a pure strategy, but looking macroeconomically, this is a kind of a mixed strategy, because there is a proportion of you playing S1 and the complementary proportion playing S2. This is a mixed strategy in a collective sense, right?
So excuse me, when you say mixed strategy, it means not that people is changing strategy, but that there are little proportion, right?
You are playing one strategy, but like you, there are many others.
But I can change, my strategy.
Not
setting, right?
Not yet.
Not yet. But the answer is mixed, you mean that I just change the...
Yeah, mixed strategy, you see, with 45% I use S1 and 65, 55 I use the other one. No. Everybody of us are playing pure strategy. But in a collective sense, I'm watching them what? 30% is using S1, 70% S2. That's the interpretation. Yes.
You're repeating the game.
Yes. The game is played.
Is there memory? You know, people you have talked before, if they are
No.
or not? This information passes
No.
on to the...
No, because it's going to be the simple thing. I'm going to model dynamics by means of the replicator of dynamics. There is, of course, interactive learning and all that. Imitation. Well, I calculated the payoffs, and I'll take this matrix, then I normalize the payoffs, and take this one, and then it happens that we have this game, right, and obtain this equilibria. Set of three equilibria. These are impure strategies. S2, S1, this is AB, ABBB, BBBA, and this is the mixed strategy. It's an interior.
What do you mean by normalized?
Yeah. What I do is take this and then subtract by this. Right.
The two columns?
Yeah. It's a kind of it's a normalization that to simplify the matrix and see when I have this, I can say which is the solution right away. Yeah.
Okay.
And then obtain this set of equilibria. The third one is the mix. So we have the ones we saw before. You see, where the language is spoken is B. But, of course, they are a strong candidate to maintain the language diversity, because then we are saying bilingual people interact using language B. But the question is that these equilibria are weak in the presence of perturbation, dynamically unstable. So they will only survive in the presence of perfect information, in the case of patriarchal and family. In that case, of course, I know that you know, we prefer, I know that you know B, we prefer to speak B, and then we maintain B, so B survives. But then, if I go away from that village and go to Barcelona, not to Barcelona, go to Bilbao, to the Corte Inglés, I'm not using B, I'm using A. That's what happens. And maybe you have some solar in the cortical and not, although the proportion is very low. The cortical cellars that no Vasco is very, very small, but there are some. There are some. So, only in the presence of perfect information, these two equilibria survive. So we are left with this mixed equilibrium. The mixed equilibrium has very strong properties, stability properties. It's asymptotically stable. Not only that, it's evolutionary stable. It's the best strategy, the best one. So any other strategy that's worse than this one. And then it is, for the replicator dynamics, the single population replicator dynamics is asymptotically stable. This is the replicator dynamics. The replicator dynamics is just comparing the expected period of one strategy relative to the average expected period. If the payoff of a strategy is smaller than the average payoff of the game, then will decrease, the population decreases. If the expected payoff of one strategy is bigger than the average, increases the population, and so on. So that equilibrium, Bayesian Nash equilibrium, is asymptotically stable. Don't forget that this equilibrium is interior. It is inside 0, 1. Features. It is robust. It is called a convention, speech convention for the bilingual people, so that they are using both A and B. Bilingual population are using A and B, both languages. But then, in the use of B in that equilibrium could be very weak. Could be very weak. You see, in that equilibrium, there is a proportion. This one, 1 minus B, are using the strategy S2. S2 is this one. Again, we are here. AB against BA. Here will we use A instead of B. That's the coordination failure. Then we predict that that's the main the main feature of the outcome that will most frequently will happen. In a real situation, we predict that that's the strategy will be widely used. Why? Because you see, we say it is non-controversial. Imagine I'm player 1. You are player 2, right? You are player 2. I mean, I'm using this, you are using this. Okay? I'm the shopkeeper. So I'm starting with A, one of these. Okay? The strategy is telling me use first the language spoken not by a minority of the society, but by everybody. Everybody understands. Buenos días, ¿qué desea usted? And then not only that, if you, for whatever reason, answers me uno, beardot auta bestia, then I will switch my code because I'm ready to use B. If I hear you speaking B. So it's a kind of non-controversial in the sense that many times given the distance between languages, if you start with B, you may find people giving excuses and being sorry, I'm learning the language, but it's difficult, but don't worry. In a year, I will be able to answer you in B and so on. So people get embarrassed sometimes. So it's a kind of threatening, starting with B. So that's why entering to the customer using A, it seems that it is softer, right? S2 is perceived as non-imposing to monowords. And then you can change the code as well. So we say this. It satisfies the principles of politeness of Lakoff, Brown, Levinson. It is also perceived as non-face threatening. If you ask me non-face threatening, the meaning of that, I forget easily what it is. But anyway, maybe you know better than I do. Face threatening is like in every interaction, there is a kind of politeness norm to avoid any threatening attitude to the person that you are talking to. Well, this is studied by Kaufman and Brown and Levinson, non-face threatening. That's why it is a soft interaction with AB. And then, you see, your strategy, BA is just, you are using the language that you are hearing. If you hear egunon, you will answer with egunon. But if you hear one of the guys, you will answer one of the guys. It's very polite as well. You just follow the language that the first one is using. But the problem is that the game now is converted into a hot dog game. And the conventionally considered hard or rough strategy, BB, so use BB in any case, is a dog strategy. And the conventionally considered polite strategy, starting with A, and then the other one is wants to speak B, change to B, is a hot strategy. And I'll show you why. So given values to the parameters to N, and C, I obtain this payoff matrix. This payoff matrix and this one have the same structure. So this is the rough strategy, the conventionally considered rough strategy, and this one the polite one. Well, the rough is dog. This one is hawk. This one is dog. This one is hawk. When two dogs meet, they cooperate. They are able to speak in the language they prefer to speak. So, BB against BB, B. We are speaking the language that we want. BB against hawk, of course, hawk obtains a higher payoff because this one has taken the risk, right? The hawk takes a higher payoff, but then the language is spoken is B as well here. But when two hawks, using these two strategies, AB against BA, then they fight each other, and instead of satisfying their preferences, the preferences of the speaking B, they talk in A. So that's the miscoordination.
Because when you are risking at the beginning,
Yes.
if finally you just speak B, that would be the first case, B, 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 B. I thought there was no cost, right? Or there is cost already, just from risking. Even if you don't finally get
No, there is no risk. Well, sorry, there is no cost.
so then
When calculating,
why do you get a zero there? Well, in
yeah,
the dot, yes. And if you finally get to use the language you wanted, you have risk, but you didn't.
yes, well,
You don't fail, right?
you see, the numbers here are not unique. They are any
I know.
positive linear transformation
Okay.
are okay. So therefore, you can change the number from here, make a positive linear transformation, you obtain any other number. But then to calculate this number, you have to introduce. I mean, you have to take into account the 4 events. Both are monoglots. One is monoglot, the other is bilingual. The first is bilingual, the second one is monolingual, and so on. You have to calculate all this, and then you get this number. But the important thing is that the structure is a hot dog game. And the important thing is that the apparently polite strategies are the hot strategies. Why? Because this against this, here the language is 8. So therefore they are against them. They are against them. Although they are willing to speak B. But then, of course, I say, well, I speak B if you speak B. But I will start with A. And then you say, I will speak B. I will speak B only if you speak B. You see, the risk, I'm passing the risk to the other one, and that one is passing the risk to me. Because I'm telling, you take the risk, and he's telling, you take the risk. And then they end up using A. Well, so that's the situation. That's the situation. Here, a dog against a dog. B. Dog is cooperative. Dog meets a hawk, but then they end up using B because eunon, and then we reach the node where B is chosen. So eunon. A hawk meets a dog, and then B is spoken. 2 hawks meet, and then the language is spoken. Well, the C parameter can be used to observe the influence of conventions, politeness norms, and so on. Conclusions. Well, we dare to say that X star at equilibrium, the mixed equilibrium, might explain what happens in real situations to minority languages. The minority languages fit in the assumptions of our model, of course, as well as the difficulties to move away from that position. Why is it so hard to save a threatened language? Says Friedman, asked Friedman. Well, the use of B in that equilibrium, that mixed strategy equilibrium, is sensitive to imperfect information, politeness norms, and other factors outside the model, such as the scarcity of formal and informal usages of the minority language, and hardly developed oral and written discursive models. You can always go to A to use A. So, given these factors, our prediction is that the Hawks strategy profile will be widely used. So that the implication is that B will be reduced to very low levels. And also, since X star is a speech convention for the bilingual speakers, then it gives it gives the equilibrium very strong stability properties. It's difficult to move away from that weakness of B, because we are referring to a convention that is evolutionary stable. So therefore it's difficult to change the situation. And then you may say, the economists always say this, well, eliminate the imperfect information, because that's at the end is one of the main reasons of this negative result, or almost negative result. Well, if you when you have perfect information, well, it is proved. Everybody knows that the language, the minority language, can be maintained, right? When there is no perfect information, you can mark or label people with something here, an alpha, right? Alpha. But then this could be an additional source of conflict. The good one starts with the alpha one. Right? So it's not easy. In Wales, I heard that they use some kind of sign. Yes, I'm not saying an alphabet or something similar, but I don't think it was very popular. And I can imagine in other part of the world it wouldn't be popular. So we are designing an experiment. We have a experimental lab, and we are designing an experiment to prove whether these predictions are correct or not. So that's the thing.
Thank you, William. A number of questions here, open issues. I don't know if anyone wants to make any other specific question or comment now. Sorry.
First of all, I like very much the new settings from which you develop the models, as you mentioned in the introduction about the models that are very different from those of what we have developed here at the Institute regarding the departing from average and Strogas and minute long models and stuff. Because I think that we faced many times with saying, well, we start with asymmetric scenario in which there is no one language that is spoken by all the people, but we try to see if this emerges somehow. But on the contrary, you just assume, I think, that the setting that is I'm going to say, like, more realistic in what we observe, I don't know, in Euskadi, we observe here, or in Catalonia, etc. Right? So, in this thing, I think it's very interesting that just focusing in the bilingual age and look at the dynamics there. So, I think it's a very different point of view, or starting point of view, and that gets new results and new ideas. I think are very interesting. And we're in this focusing on very first interactions. Right? I mean, we have a lot of discussions about I don't know with Raúl also. I think about but if I speak with Raúl in one language, then maybe he's already familiar with that. I know him, right? So this language just gets fixed, and in our models there's a lot of let's say change from one language to the other. And that was some of the criticism that we get, right? And I think that you focus only right on the boundaries, let's say, between when there is no between each other, right? Because I think it's also new thing regarding the model that it's very interesting.
Of course, I mean, this is an ex-ante. Ex-ante, I don't know. Then I have some interaction with you, and then the next day, if I have the opportunity to meet each other, and then, of course, there is a revelation someday. So you know.
So you know.
Yes, in that case.
Exactly that. But anyways, just a final comment that I think of course, it's very different. But you talk about this how the mixed strategy, right? It just makes stable the coexistence of the two languages, even though that the number of bilingual is very low, right? Due to this whole strategy. I'm glad this result about the high volatility. You know, this when people just doesn't get very attached to the model of Aaron Strogatz, that we just developed network and stuff. We see that when people is just changing the language of the other, it's kind of actually a kind of parallelism, even though the modeling is very different. We also have this coexistence due to the lack of attachment, right? Of the
coexistence.
Exactly. Even though that also the bilingual might not be the majority, right? So it's, I think, but there are some parallels.
Going to the boundaries.
To them? Are going to boundaries depending on the exactly on the. This depends on the value of this attachment, let's say, of willing to change to the other's language, right? And this last strategy that we comment on is like you speak the language of the other, right? So you try to adapt, right? To the not to your own language, but changing maybe to the other one. So I see some.
Perhaps we can go on discussing that.
Yeah,
the general content. Now there are other questions you can probably.
No, I said that you have many parameters. In the model, you have all this alpha, P, Q, R, probability distribution, that of the other, M, N, and C. You have all this branching. You have many parameters there.
Yes.
But at the end, they all have disappeared. Okay? So your conclusions do not depend on the. Just choose a couple of values.
Yes,
You choose M, N, and C, and then you draw. Is a general conclusion? Oh, it's alpha for there.
Yes, say the parameters, yes.
No, I see it all the parameter alpha. No, so that I thought some of the parameters have disappeared.
No, they are all here. What I've done then, to obtain the payoff matrix is to give M4, N is 2, C is 1, to obtain the numbers. To obtain this matrix. And then when I had, not with the numbers only, but when I had this is when I realized that this is a hot dog game. So then I know the result. This is the result. The question is that this belongs to the open interval 0, 1. Okay. But then this is the number of people that bilingual people who will use a strategy, this one, right? But then, since this could be near 1 or near 0, I realized that the prediction is this will be near 0. So that's why you can have an equilibrium in which bilingual people use both languages in the interactions, but which one will they use more? And then the prediction is A, because the strategies they will use more frequently are these two. So therefore, this will be almost 0. And y 1 minus x star almost 1.
One question. How stable will be the equilibrium if there is a perturbation that somebody, the tender says, good morning, Económico. Buenos días, Euro. Which is not unusual. Then, of course, that there is a new set of steps. But, is this going to be a perturbation of this equilibrium or expect results to be similar?
Well, maybe the problem will be how to model that. How to model that will be the kind of drift. Modeling drift there. But
You start the game.
You tell you're bilingual.
No, maybe you just think because you are polite.
A, for example, can start a conversation in B even though he is unable to speak.
Yeah, that's
And you can keep the, and that happens very often. I mean, that's, you go and you are polite, say, okay,
Yes,
you don't use B.
you speak in B, the iconic phrases, right?
Yes.
yeah, but at the beginning of the conversation,
Sí, adeu, bon dia, or agur, non, but then it goes to
No.
yes, but then these are refining the model. The model is so far
You are
simple one.
Any other? Yes, Lucia.
I don't have a question or a specific question. I just have a comment on the actual role of imperfect information in the actual survival of the language. I'm just wondering how many times a day do we actually speak with people whose language we don't actually know? Like, I think that in language survival, what is actually important is the conversation we have with people we actually know. The conversation we have with people we live with, or with people we work with people we actually talk with every day. But the language I use with someone I meet at a corte inglés, I don't think that actually plays a role in language survival. But I don't know. It's a question I'm asking myself. So I'm not expecting an answer.
But you see, Lucia, I know perfectly each one here if understands Spanish or not, but he doesn't know who understands Spanish here or who doesn't.
Yes, but Spanish is not threatened because of that.
Well, but
We're talking about language survival, aren't we?
it might be better here.
Yes, I understand the question, but
Yeah.
It
No, it's not a
happens.
question, it's just a comment. I'm just thinking about that.
well, you can discover after 2 or 3 interactions.
Exactly.
It happens many times. It happens many times that you end up with this strategy many times, and then I play this game continuously, and then I discover that when it occurs this that bilingual people you say many times you say, well, this is going to be in one shot, and then we leave, and then we go back to our places, and then in our places you know who speaks Catalan, English, only Catalan, because you. But I mean, it is something that you people studied with community networks. Right? Here, the analysis is what's going on outside that community network, so that you don't have an island, little islands of bees used, and then when you go to one island to the other, and you don't know anyone here, and then even though you are bilingual, you will use A, because A is, everybody knows A here. It's a common knowledge. So we concentrate on that because usually in the strongholds, where when you go to certain towns in the country, you have a board saying this is a Vasco speaking town. So when those people from that town go to another place, they don't use B, they don't use plus. It happens in the Basque country and in other places as well. The interaction is taking place in any, right? So B is kept in the historic areas, but not in the new areas for developing countries and so on, where new economic areas at the level of university and so on. Of course, after many interactions, you end up knowing who knows and who doesn't, and so on. But there are many interactions that don't occur among the bilingual people that don't occur in
Okay, I think we can finish the public discussion here and continue later on with private. Thanks again. Muy bien. So I don't know if perhaps you're around the other.
Yes, any moment it's good for you, it would be very nice.
Same words that you were using perfect information.
Yes.
There was no rebuttal from him. So
But I think yes, to see how this can be also mapped to some French locations. So in the end, there would be interdisciplinary. So I said to them, in the afternoon, I don't know.
tu seminario
You are
For lunch and then later just some more time on
try to discuss that.
Yeah, so we'll meet in then.
We'll meet at some time or we'll call each other.
Yeah, we'll call you.
Good.
Okay.
They know where you are.
Muy bien. Bueno, ahora voy a switch code.
Ahora cambiamos de código.
Hacemos code switching.
Llegaba así con el portátil, no te...
Ahora estoy buscando.
Estaba muy sorprendido de tu historia. Yo le dije que no, y dice, ¿por qué hace ahora Xavi? Y digo, está pensando.
Es extraño. Es extraño un doctor que piense, ¿no?
Y me dijo, pero hombre, después de todo el esfuerzo que ha hecho.
Claro, ha resultado la inversión.
Sí, luego presionar si quieres.
Una inversión para la ciencia, muy altruista lo tuyo, ¿eh?
Toda la inversión. ¿Qué tal la inversión?
Sí, no, bueno, más que ahora sí que estoy en un momento así de resituación, digamos, a nivel de sí, también en tema y bueno, estoy mirando ahora, de hecho, postdocs en grupos de sociología, ciencias sociales y tal, que me interesaría más vincularme en este... Economista no lo he pensado aún, pero alguno lo conocía. No, pero sí que estoy...
Pero los interrogas que pagan muy bien.
¿Cómo? ¿Perdón?
Los interrogas que pagan muy bien.
Sí, una cierta edad necesita.
Ah, te lo pides.
Estoy buscando mi... Ah, está, ahí está.
Está,
sí que estábamos viendo.
No lo sé. Yo te he dejado con Edu porque he decidido que
Es que
estas
ya-
cosas,
ya
cuantas más personas intervienen,
el nivel de...
En el avión me he dado cuenta, como decía la gente, que todos sus índices me los había comido. Claro. Y entonces, en un sitio estaban bien, pero al final no me enteraron en qué sitio estaban bien. Si aquí o aquí. Claro. En el avión puedo poner eso.
Pues no sé qué estábamos viendo, la verdad.
Si estaba ya...
El cable está al portátil, pero
No, pero es que hay dos cables, pues que hay dos modos,
no
no
entiendo por qué ha funcionado.
Creo que hay dos salidas, ¿no?
Hay dos
Corta esto
salidas.
y puede salir por aquí o no.
Sí, hay dos salidas.
Si no recuerdo mal cómo estaba el tema.
Usted ibas a decir algo, ¿no?
No, yo iba a decir, era porque como estamos en casa de los físicos, que... dices, si se va a pasar Xavi al mundo de los economistas, mira, además es mucho más fácil de entender, ¿eh? Es mucho más fácil de entender todo esto que pues muchos artículos.
Es el mejor elogio que le has hecho a José Ramón. De que este es un seminario más fácil y más bonito que no estas cosas con películas y tal que hacemos nosotros.
Es que, bueno, yo mismo de los vuestros 5 años después sigo sin entender la matemática detrás. Y esto, sé que si me pongo lo entiendo, ¿sabes?
No tenemos ningún árbol tan grande nosotros para...
No, da igual, tenéis una mini ecuación así de la cual no entiendo, nada. Vale, yo creo que es más que trasciende.
Es el modelo.
El modelo lo
Trabajar haciendo code switching.
Ahora vas a Puedes pasarte a la economía, sí.
A ver, por favor, no dejamos arriba lo que esté
A ver, gente, ¿eh?
Oye, pero
Sí, yo también.
Listo, no.
Ya está todo para.
sí, no, básicamente es una probabilidad de usar una lengua u